I'm from Potomac Highland Regional Jail.
I'm Charlie. I'm from Southwestern Regional Jail.
Today we're going to show you a math tutorial on the system of linear equations. Okay, the system of linear equations is used to determine the point at which two lines intersect on a graph.
There's two ways to solve the system of linear equations. The first one is called the substitution method, and the second one is called the elimination method. And Jen's going to show you the substitution method, and then I'll come back in and show you elimination.
All right. Okay, so as we mentioned, we're going to start with the substitution method, okay? And a lot of times you want to use this if the equation has a variable by itself. So if we look at our two equations, we can see that A is a variable by itself. So this is why substitution would be a good option, okay? So let's take a look. Step 1, isolate the variable A, okay, on one side of the equation. So to do that, what we need to do is subtract 3x on both sides of the equation. We're going to cancel and drop our A variable down. And then we cannot combine unlike terms, so we're left with 17 minus 3x. Step 2 is we're going to substitute for A into the second equation. As you can see, we just solved for A. Okay, we know that A is equal to 17 minus 3x. So we're going to take this and bring it down here now. So 2 times 17 minus 3x plus 2x equals 18. Okay. The next piece here, step 3, solve for x. So we're going to distribute and combine like terms. So we're going to distribute our 2. Okay, 2 times 17 gives us 34. 2 times a negative 3x gives us negative 6x. Drop everything else down. Okay. The next thing we want to do is combine our like terms. So a negative 6x plus a positive 2x is going to give us a negative 4x. And we're going to, again, drop everything else down. Okay. The next piece here is we are going to subtract 34 on both sides. Cancel this side out. And we're going to be left with a negative 16. Okay. We're going to drop our negative 4x down and divide by 4. X is equal to 4. Okay. At this point, we know that x is 4. We're about halfway done because we also need to find what a equals. So step 4 is that we're going to substitute our x value to find our a value. Okay, again, x is 4. We're now going to substitute x back into our equation. Okay. At this point, we can drop our 2a down. 2 times 4 is 8 equals 18. Okay? We want to combine like terms, so we're going to bring the 8 over. 2a equals 10 there. Divide by 2 on both sides. A equals 5. So at this point, we found our ordered pair. 5, 4. And this is the point on a graph where our two lines would intersect. Let's try another example. Okay? Where does the line with the equation x minus 2y equals 4 intersect with the line of the equation 6y plus 5x equals 4? If I look at my two equations, I can see that the x is an isolated variable, so we're going to solve here. To do that, we have to add 2y on both sides. This will cancel. Now x is isolated by itself. Okay, we cannot combine like terms, so we're going to just add them together here. Now that we know our x, we're going to plug this into our other equation. So 6y plus 5 4 plus 2y. Okay. Next step, we have to distribute. Drop this down. 5 times 4 is going to be 20. 5 times 2y is going to give us 10y. Okay. Again, we would like to combine our like terms. So 6y plus 10y is going to give us 16y. Okay. The next piece is to combine our like terms. So we're going to bring the 20 over. Drop our 16 down. Divide out by 16. Negative 16 divided by a positive 16 is going to give us a negative 1. Again, we've solved half of our equation because we now need to find out what our x value is. So we're going to take the y and come back over here and plug it in. So we have x minus 2 times negative 1 is our y equals 4. Negative 2 times negative 1 is going to be a positive 2. A negative times a negative is positive. Drop this down. Combine our like terms. X equals 2. Again, we've now found our ordered pair. It's going to be 2, negative 1, and this is the point on a graph where these two equations would meet. Thank you.
Thanks, Jen, for showing us how to do substitution method, and now I'm going to show you the same way to solve systems of linear equations by the elimination method. When you use the elimination method, you can use it when the variables can be canceled out by addition or subtraction. So the object of the game is you have two variables, the x and the y, and you want to get rid of one of the variables. In this particular example, if you'll notice, I have a positive y and a negative y. If I add positive y and negative y together, those will cancel out, and therefore that's called elimination because you have eliminated the y's, therefore you can find the x. So I'm going to do addition on this to eliminate the y and solve for x. 2x plus 3x is 5x. Positive y plus negative y cancels out. That's why you eliminate the y. That's called elimination. And then 9 plus 16 is 25. To find out what x is, then you divide by 5 on both sides. 25 divided by 5 is 5. You have x equals 5. Congratulations, you have half the answer. Now you have to take the x equals 5, plug it into either one of these equations to find out what the y is. Okay, step 3, we're going to substitute our x value in for one of the other equations. Either one will work. Substitute x equals 5 into one equation or the other, doesn't matter, and then you can solve for y. So you can take the 5 and put it in for this x, or you can take 5 and put it in for that x, does not matter, either one will work. I can do both if you want me to. 2 times 5 plus y equals 9. 2 times 5 is 10. 10 plus y equals 9. To get the y by itself, you would subtract 10 on both sides. These cancel out, and y will be negative 1. To prove that's true, I'll do it on the other equation as well. You don't have to do both of them, one will be sufficient. Put the 5 in for the x. 3 times 5 is 15. 15 minus y equals 16. Now this is a negative y, and I'll show you what to do with that in the next step. But to get the negative y by itself, you have to subtract 15 on both sides first. These will cancel out. Again, this is a negative y, and negative y equals positive 1. If negative y is positive 1, then positive y equals negative 1. And you can do that by either dividing by negative 1 or multiplying by negative 1 on both sides. Either way I did it, either equation, and I substitute that 5 in for the x, I got y equals negative 1. So it works both ways. You don't have to do both of them, just one will be sufficient. So what we just found out was x is 5, y equals -1, gives our ordered pair of 5, -1. So if we graph those two lines, they will intersect at 5, -1. Okay, elimination method. Let's look at another example. This one's a little more difficult than the last one because if you'll notice, neither the x numbers or the y numbers will match up. So if you add these two together, these two x's will not cancel out, nor will the y's. And if you subtract the two, the x's nor the y's will cancel out. So what you have to do is, you have to either match up the x numbers, which you could do both of them. They would match up at 15. So you could make this 15 and that 15 to subtract. Or you could match up the y numbers. This is a +1 and a +4. The easiest way to do this would be make this +4 and subtract, or make it -4 and add. Doesn't matter, either way you want to do it. We have chosen to change this to a -4. And in order to do that, we take this whole equation and multiply by -4 on both sides. And when we do that, we would get -12x minus 4y equal to -36. Then I'll take this equation and match it up with the second one and eliminate the y's. Okay, now we're going to eliminate the y because we multiplied both sides by -4. And when we did that again, we took this top equation and multiplied by -4 on both sides, which gave us -12x minus 4y equal to -36. So now I can cancel out the y values because the top one is -4y and the bottom one is +4y. If I add those two together, I will cancel out the y's, thus eliminating y's and have only x's to find the answer to. On the next step, to eliminate the y, we are going to add -12x plus 5x is -7x. -4y plus +4y will cancel out, thus eliminating the y's. And then -36 plus 22 is -14. To find out what x is, we divide by -7 on both sides. And x will be 2. Congratulations, again, you have half the answer. We know what x is, now we got to find out the y. Okay, again, we have the x equals 2. We can put the x equals 2, we can put 2 in for this x, or you can put 2 in for that x. It makes no difference. You can do either one of them, it'll work. I can do both if you want to prove that it works. 3 times 2 plus y equals 9. 3 times 2 is 6. 6 plus y equals 9. To get the y by itself, you will subtract 6 on both sides. And y equals 3. If I put x equals 2 over here, if I substitute 2 in for x, I'm going to get y equals 3 again, just to show that either one will work, but you don't have to do both. One will be sufficient. Put the 2 in for x. 5 times 2 is 10, plus 4y equals 22. To get the 4y by itself, I will subtract 10 on both sides. These cancel out. 4y equals 12. And if I divide by 4 on both sides, y equals 3. So it doesn't matter which one you put it in, it works on either one, but you don't have to do both. I'm just showing you both in case you don't believe me that it works. So I have x is 2, y equals 3. My ordered pair will be 2, 3. The graph of those two lines will intersect at 2, 3. And I think we are caught back up. Good luck and have fun doing all that editing.
Make me look good.
James Oates. Real world application. We have 2 different equations that we're going to solve. Jen's going to do the substitution method on this one, and I'm going to do the elimination method on this one.
Alright, let's take a look at this problem here. A portion of $100,000 was invested with a return of 3% after 1 year. The remainder of that investment was invested at a return of 1%. The total return on the investment was $1,800. How much money was invested at each rate? So what we need to do first is develop two equations, okay? The first equation we're going to do is take investment 1 plus investment 2 and know that it's going to equal our total investment of $100,000. So we're going to make investment 1 X, investment 2 is going to be our Y. Then we look at our second equation. We know that we got a 3% return rate and a 1% return rate. So if we multiply 0.03 times our first investment plus 0.01 times our second investment, which is Y, we know that we will get a return rate of $1,800. Okay? So those are the two equations that we're working with. So let's go ahead and solve. Okay? I'm going to make the X by itself. So I'm going to subtract Y from both sides. That means that X will be equal to 100,000 minus Y. So we're going to take this information and go ahead and substitute it into our X. So 0.03 times 100,000 minus Y plus 0.01Y equals 1,800. Okay? Just like before, we're going to distribute. Okay? 0.03 times 100,000 is going to give us 3,000. 0.03 times Y, we're going to combine. Drop everything down. Okay? Just like always, we want to combine our like terms. Okay? A negative 0.03 plus a positive 0.01 will give us a negative 0.02. And we drop everything down. Okay? Now we want to combine our like terms here. So we're going to subtract 3,000 from both sides. This will cancel. Okay? We get 1,200 negative here. And then we're going to drop down our negative 0.02y. And the last piece here is we're going to divide this out. On both sides, this will cancel, and we're going to be left with y. Make sure you get that. Y equals 60,000. Okay? Again, we got half of our answer here. So now what we need to do is take this answer and substitute it back into our original equation, which is x plus y equals 100,000. Okay? So x plus 60,000 equals 100,000. Okay? And from here, if you subtract it, this side cancels. We will be left with x equals $40,000. Okay? So what this information tells us is that the first investment was $40,000 and the second investment was $60,000.
Thank you, Jen, for showing how to do this problem with the substitution method. I'm going to do the exact same problem, and I'm going to do it with the elimination method to prove to you either one of them work and we'll get the same answer. So here's our two equations. I am going to take this equation and slide it over under this one. I'm going to line them up for you. And the reason I did that is because elimination, again, is we have two variables and we want to eliminate one of them. I have 1x and 0.03x. If I add or subtract, I'm not going to eliminate those x's. I have a 1y and a 0.01y. if I add or subtract those, I won't eliminate them either. So I have to change one of these equations to get them to match up so I can add or subtract the coefficients, which is the number in front of the variable, to eliminate one of them. So if you'll notice, both of these decimals are in hundredths. So I'm going to take the bottom equation and multiply it by 100 on both sides. So I'm going to take this original one, I'm going to multiply by 100 on both sides. I'm going to distribute this and I'm going to get 3x plus 1y equals 1800 and 2 more zeros, 180,000. So now in place of this equation, I'm going to slide this one over. So now I've got the original one of x plus y equals 100,000. And my new equation of 3x plus 1y equals 180,000. I'm going to use these two equations and I'm going to eliminate the y for you. If you'll notice, I have a positive y, which is positive 1y, and I have another positive 1y. The only way to eliminate 1 and 1 is not add. If I add them, I'll get 2, so I have to subtract on this one. So I'm going to subtract both of these to eliminate the y's for you. I have 1x plus 3x. I'm going to subtract. I'm going to get negative 2x. 1y minus 1y will cancel out. And if I subtract 100,000 minus 180,000, I'm going to get negative 80,000. To solve for x, I'm going to divide by negative 2 on both sides. Negative 80,000 divided by negative 2 is 40,000. Again, congratulations, you have half the answer. I can take that x, substitute it back into this equation, or that one, or even the one I made. It does not make any difference. You put it in any one you want, and you'll get the same answer. I think for this purpose, this one looks the easiest. I'm going to choose it. So I'm going to go x plus y equals 100,000. I'm going to substitute my 40,000 in for this x. 40,000 plus y equals 100,000. If I want to get the y by itself, I will subtract 40,000 on both sides. These cancel out, and your y is 60,000. So as we said previously, we got the same answer no matter whether we did substitution, which is what Jen did, or elimination, which I did. We get the same answer. The x is 40,000. And the y is 60,000. That's your ordered pair, meaning your first rate that you substituted in, you invested $40,000 at 3% and you invested $60,000 at 1% to get an interest of $1,800. Next, we have some test-taking tips. We have two different examples. I'm going to have Jen to come up and explain example 1 to you, and then I'm going to show you how to do example 2.
Okay, so again, these are some sample questions that you may see on a test. Consider this system of linear equations. Okay, there's equation 1 and equation 2. Which is the value of A if the solution of the system is 5, 1? Okay, so here's our A that we're trying to solve for. All we need to do at this point, this is our x and this is our y. So wherever we see x, we're going to put 5 in. Wherever we see y, we're going to put 1 in. So ax minus 5y equals 15. A times 5 minus 5 times 1 equals 15. Okay? So we now have, if we want to rearrange that, we have 5a minus 5 equals 15. Combine our like terms. So we add 5 on both sides. Cancel. Okay? Okay, 5a equals 20. Divide this by 5. We get a equals 4. Okay, so choice C would be our answer there. Again, all we had to do was take x and y and plug them into the equation and solve for it. And that gave us our a value.
In example 2, we're going to solve the system of two equations. Jen has already showed you substitution method. I have showed you elimination. What if you forget and panic and don't know how to do either one of them? So, substitution was one method. Elimination was another method. In this particular problem, they already give you a choice of answers to where those two lines intersect. If you don't want to do the substitution elimination, you can just plug in the x and the y in each of these two equations to see which answer, which solution, which ordered pair works in both equations, because they have to work in both equations for those lines to intersect. So if all else fails, we call it plug and chug. So I'm going to start with A first. X is 1, y is 5. 2 times 1 is 2, plus 5 is 7. That one don't work. If it don't work in one, it doesn't matter if it works in it. It has to work in both of them. Okay? So now let's try B. Let's try -2 and 7. 2 times -2 is -4. -4 plus 7 is not 6. That one don't work. Let's try another one. Let's try 3 and 1. 2 times 3 is 6, plus 1 is 7. That one don't work. So hopefully this one's going to work. It should be D. We've got to make sure though. It has to work in both equations to be the correct answer. We have 2 times 4 is 8. 8 plus -2 is 6. It works in that one. 4 times 3 is 12. 4 times 2 is -8. 12 and -8 is 4. It works in both of those equations. I'll show you that to make sure you understand that. I'm going to put the 4 in for x and the -2 in for y. And here is the top one. That is 8 plus -2 equals 6. We said it does work. And then the bottom one, 3 times 4 plus 4 times -2 equals 4. 4 times 3 is 12, plus -8 is 4. That is correct. And we're still what we told you to begin with. So if all else fails and they give you a choice of answers, and you don't want to do substitution elimination, we have given you another choice. You could just plug them in to find out which one works.